Hello students, in our previous slide we have discussed about the infix notation. In today's slide we will be discussing about the Polish notation or prefix notation. The prefix notation refers to the notation in which the operator is placed before its two operands. Here no parenthesis is required. As in infix notation, we used to write the expression as A as a operand, B as a operand, and operator is placed in between them as A plus B, whereas in prefix, the operator will be placed before the operands, that is, plus AB. There is a reverse Polish operation, or we can say it as reverse Polish notation, which is known as postfix notation. The postfix notation refers to the analogous notation in which the operator is placed after its two operand. That is, we can write the reverse Polish notation or postfix notation as first A, B, and then the operator plus sign. Again, no parenthesis is required in the reverse Polish notation. The stack organized computers are better suited for postfix notation than the traditional infix notation. Thus, the infix notation must be converted to postfix notation. The conversion from infix notation to postfix notation must take into consideration the operational hierarchy. The expression for adding the numbers 1 and 2 in prefix notation is written as plus 1 2 rather than 1 plus 2. For instance, the expression that would be written in conventional infix notation is as if we are taking a arithmetic expression as 5 minus 6 and that is in between parentheses multiplied by 7 can be written as prefix as the parenthesis will be solved first. So 5 minus 6 will be written as minus 5 6 and the parenthesis is given. Now minus 5 6 is one operand and 7 is the another operand, and in between them the operator is multiplication sign. So the multiplication sign will come to the first place and then the two operands. So finally we get the prefix notation as multiplication and in parenthesis minus 5 6 and at the last the operand 7. So this parenthesis is not necessarily written, but it is written for not having any confusion. Since the simple arithmetic operator are at binary, any prefix representation of theirs is an unambiguous. So here we will see one another expression which is in infix notation, and we will be putting it to postfix notation. So here the infix notation expression is a minus b in parenthesis multiplied by c divided by d plus e in parenthesis plus f. So when we will be solving, and this is to be noted that this is solved completely according to the precedence priority and the associativity rule. So according to the precedence priority, we need to solve the brackets first, and at the second step we will be solving the power. The third step we will be solving the multiplication and division, and at the fourth step we will be solving addition and subtraction. And according to the associativity rule, the power will be solved from right to left, whereas the multiplication, division, or addition and subtraction will be solved from left to right of the expression. Here, in the given example, we first perform the arithmetic inside the parenthesis, that is a minus b and d plus e. The division of c divided by d plus e must be done prior to the addition with f. After that is multiplied the two terms inside the parenthesis and bracket. So finally we get the postfix notation as ab minus cde plus divided by f plus multiplication. So here are some more conversion examples from infix to prefix and postfix. This all example conversion are done with the precedence priority and associativity rule. So let's see the valuation of any expression, or we can say the valuation of basically postfix expression using a stack. So if we are evaluating any expression, we need to convert into postfix expression and then do the valuation. As we have studied in our previous slide that the infix notation must be converted to the postfix notation, and the conversion from infix notation to postfix notation must take into consideration for operational hierarchy. So let's see the algorithm first. At the very first step, the stack and its value is initialized. The stack is initialized with given with the top equal to 1 and the stack top is assigned value 0. So this is how the stack has been initiated. At the very second step, we need to evaluate the prefix expression until we reach the last character of the expression. So it's written as repeat until last character. So here we get temp and next character postfix operation. This is temp is temp is the single character of the expression. When we are taking any expression, for example, we are taking a multiplied by b, so here a is one temp, multiplication is one temp, and b is another temp. So temp is each character, okay, each character of a given expression. So here is the condition: if temp is a digit, that means if tenth is a operand, then what we need to do? Then we need to push as top temp. Okay, so here push operation is done in the stack S at the top position, and what is the data element that is pushed? That is temp, right? Else, there is the condition where there is a if part and there is a else part, that either if it is a operand then it is pushed into the stack, else if it is a operator, right? If it is a operator, then what is done? If it is a operator, then operand 2 is popped out of the stack from the top position. Again, operand 1 is popped out from the stack at the top position, from the top position. And what is done? Then the value is been evaluated. The value evaluated is whatever operator is been found, that operation is been performed over operand 1 and operand 2. Then the value or the output is again pushed into the stack. Okay, so this is how we continue until we reach the last character of the expression, of the postfix expression. right? So if there is a operand, it is pushed into the stack, and if there is a operator, then two operands are popped from the top position of the stack, and that operator's operation is been performed over operand 1 and operand 2, and the value is again pushed into the stack. And finally, when we reach the last character of the stack, then the result is at the stack top position, and we need to return the address, or we need to get the address by the pop operation from the stack. Okay, so this is returning the address from the stack. So we will be seeing this thing by one example. So here is a post expression, that is 546 plus multiplied by 493 divided by plus multiplication. So here we need to solve that. First we initialize the stack. Initializing the stack means we take top is equal to 1 and the first element is equal to 0. Okay, so what we need to do, we need to check the expression. If there is operand, then it will be pushed into the stack. So there are three operands at very first step, that is 5 4 6. So into the stack, first 5 is pushed, then 4 is pushed, then 6 is pushed. At the next step we see one operand, that is plus sign. So we already know when we will see one operand, or else we can say when we don't see any operand and we see a operator, then two elements will be popped out from the stack, that is 6 has been popped out and 4 has been popped out. And what is done now, in this two operands, that operator operation has been performed. So 4 will be added to 6, that is we will get 10, right? And the 10 answer will be pushed back to the stack. So in the third stack we can see that 10 is pushed into the stack, right? Next we see another operator, that is multiplication sign. So it means that again two operands will be popped out from the stack, that is 10 has been popped out and 50 has been popped out, and multiplication operation is been performed on this both operands, that is 10 multiplied by 5, and we get the result as 50, and 50 is pushed into the stack, right? Again after that we need to read three operands, that is 4 9 and 3. So again after 50, 4 9 and 3 will be respectively pushed into the stack. After 493 we see one division operator. So when we see the division operator, there is two values to be popped out from the stack. Okay, two values are operand 2 is 3, operand 1 is 9. Okay, and we need to perform operation on operand 1 divided by operand 2, that is 9 divided by 3, and we get the answer 3, and we push the answer into the stack. So here in the stack we get the solution and have entered into the stack. Okay, next we see one addition operator. So addition operator means again two elements will be popped out from the top, that is 4 and 3, and we get the result after adding as 7, which is pushed into the stack. After that we have a multiplication operator. That means again two elements will be popped out, two values will be popped out from the stack, operand 2 as 7, operand 1 as 50, and multiplication operation is applied on operand 1 and operand 2, and we get 50 multiplied by 70, and we get the answer as 350. So finally this postfix expression has been solved by the stack, by the operation on stack, and we get the value as 350. So fine, at the last step the value or the answer will be popped out from the stack and we will get 350 as